ramę.
Którą? Tylko to pani połącza.
Akurat sobie zdążę za ten czas przenieść się do góry.
A, dobra. No to...
Ale wiadomo, bo to będą wszystkie prezentacje uczestników z tego komputera szły, no nie?
Tak, oni
Dobra.
przypinać na włączę inny slajd, a później ten pulpit, który tam jest na...
Bo będziemy się bardzo szybko przepinać, bo to będą 8-minutowe. Dobra?
Włączony mikrofon jest.
Wiem. Hi, okay. Welcome to the final presentations of the ScienCon 2022. And this is basically this big moment, the big evening, the big afternoon for now, when we will see what exactly did you came up with during the last 24 hours. So basically, for me, that's the most interesting part, because all the time when you were working, I was trying to finish off a couple of other things and also basically get some sleep after the last couple of weeks. And so because of that, I have no idea what any of you prepared. So everything, all of it will be new for me and for most of the organizing committee and volunteers. But it will be still interesting for them to see the clear results of your presentations. Okay, so without much further ado, we can start, basically. And first things first, that's the order in which you will present. I have all of your presentations on my laptop. So basically, you will use this laptop for the presentations. I knew I forgot something. Jakub will bring you in a moment laser pointer and a thing to click on your presentations. It will be easier for you to manage. And basically, I need you to remind you what are the rules of the presenting. So basically, each team will have exactly 8 minutes. And after 8 minutes, we will have one question from the mentors. The mentors. OK, now I always hear the mentors. And basically, I will time you for this 8 minutes. And once your 8 minutes is up, I'm basically taking over, so be clear on time. And then we'll have one question from the mentor, and the next team will come up with their presentation. Okay, let's see if we can get the clicker, or we... Okay, we won't get a clicker for right now. Team number 1, so Omega Psi Xi. Come here. We are actually waiting for the pointer right now.
Okay, the time is not running, right?
Yeah, the time isn't running until I will tell you clearly when the time starts running. Do you want? I will maybe, hopefully. Here's your microphone, and basically here's your presentation. So.
I think this works clear.
Can you manage without the clicker?
It's fine. It's fine. Sorry for that. It's okay. We forgive you.
Oh, thank you. Okay, so. Oh, we have a clicker.
Oh, we have a clicker.
We have a clicker. The clicker comes. The clicker runs. The clicker jumps.
Okay, so. The clicker falls. Take it.
Will you be responsible for that?
Check it. So it's for you.
Okay, so Omega Psi Xi. The time starts once I'll find my timer. The time starts now.
Okay, hello everyone. We are team Omega Psi Xi. At least 75% of it. Jan is in the audience. Our challenge was dark side of digitalization, and the problem we recognized was toxic work conditions, stress and anxiety affecting productiveness of workers. So we decided to use neural network, improving working conditions.
Okay, so wait, that was a spoiler. Okay, so unhappy workers, they are actually a big problem to employers. They don't actually care for your well-being. I mean, of course, they don't do that. But unhappy workers are unproductive, so it's a full circle, right? And especially during the pandemic, workers deal with a lot of stress, anxiety, and burnout, and that's why we have like a rotation of employees, which is definitely not something that the employers want. And I'm sure like most of you also experienced some of these aspects during COVID. So what do we do against that? This was an animation that's not working anymore. So let's ask our beautiful friend Jan, who's not presenting here. He obviously wants a higher salary, which I mean, it doesn't really fix a shitty job, does it? So it's not, he's still gonna be unhappy afterwards. And maybe he also wants to work remotely. Maybe that solves his problems. But usually that also leads to loneliness and like depression, and you're still seeing a depressed Jan. And maybe he should change a job, but Jan actually like has a history of leaving 3 jobs in the past. So there's definitely something else going on. This is also not the solution. So we need something. Like what we want to do is like gather data, be it psychological or external, like something like watching his behaviors and things like that, and implement a deep learning algorithm to determine what the actual problem is, and then present a solution to the employers.
Okay, what could we actually measure? We want to divide this for 2 parts, and external factors would be, for example, office arrangement, amount of light workers are getting, noise level, oxygen level, maybe air conditioning. Psychological factors would be gotten by some surveys, some questionnaire. We could measure group dynamics, we could measure their habits, how often they are late for work, how often they are standing, walking. We could also use cameras in the office and image recognition to determine their emotions.
So now you were wondering if we had some technical idea about it. We were thinking problem, we could cluster the individual data that we are collecting into some small groups And for that, we are using an artificial intelligence algorithm. With this cluster data, we could then train a neural network algorithm to basically obtain the problem that we were looking for the company. And with that, with a set of solutions, we could then also provide the company, okay, you can solve this problem using this or these other solutions. At the same time, we use this algorithm to do some research, and not only for the artificial intelligence problem, where we can improve this clustering by tuning the parameters, but also in the neural network by training the data from different data sets and then avoiding overfitting. And then in the last step, what to do for this problem, we could do some research by providing new and new solutions.
Okay, right now this is April 2022. This is our point zero starting point. We are at ScienceCon. We have help of our amazing mentors. In 4 years from now, I will be already after my master's degree related to machine learning, and I will take postgraduate school in IT project management to help our startup company. Jan will also be after his master's in data science in Munich. Cihat?
Yeah, so I will have actually switched from physics to psychology to help like people who are struggling. So that's what I'm gonna be doing.
In my case, I will focus then in cybersecurity in the European Institute for Information and Technology, and then doing some courses in data privacy law in the Stanford University. And after 2 years doing that and training myself, we will try to set up already a startup. But for that, we for sure fail. But we learn from that, and we want that as well. And we will try also to already search for funding for our project, because that's our really key point in this point, right? And Shihad?
Yeah, so meanwhile, I'm back at academia. That's where all the depressed postdocs are, right? So that's where I can learn the most. And yeah, Kasia?
I will take some marketing course so that I will be able to advertise our company better and be present at every stage of its life cycle. Jan will be actually in Oxford practicing his English and speaking in front of the crowd so that next time he's advertising our company with us, but also he will be creating networks and looking for specialists from various areas. In 2030, David?
Yeah, then Jan will be really developing this neural network in other startups to know what can we get from them. And in my case, I will then switch into consulting companies to really gather this experience from them and to also look for experts in different areas, especially human resources department, because I think that's a key point as well for us. And after, again, 2 years doing that, we'll try to convince them to join us in this crazy idea and hopefully successful. And we, of course, will start with this startup. And
Yeah, so if I didn't do something stupid now, I should have actually gotten my doctorate by now in psychology. So I can actually do therapy now and research in psychology. So with these two expertise, I can actually help our startup a lot. So, Kasia?
As you can see, in 38, we are a very successful company. We are joking, but not completely. If you want to invest your money in our very promising startup, you can find us after presentation. You're welcome.
Then for the last slide, we have the SWOT analysis. Surely, I think that we have a really strong strength because we are really a skilled and diverse team. Then, unfortunately, we also have weaknesses, of course. One of them is the lack of experience for building this whole process and algorithms. But we also have a huge opportunity because big data and artificial intelligence is, of course, a huge trend nowadays. And of course, we will look for good information and advertising there. And one of the main threats, as we were trying to avoid as well, will be this treatment of sensitive data in data privacy. So,
Okay, at this point, we really want to thank you to all the participants for your attention, to organizer for bringing our dream team come true, and to all our amazing mentors, because your help was really great. Thank you very much.
Great, thank you. You were perfectly in time, which is always great. And one technical note, or rather two technical notes first, because there's the camera here, and the camera starts somewhere around here and then goes that way.
Wow.
So just for the future teams, like if you could present a little bit more that way. That's the only technical note. Thank you very much. And now a question from mentors. Unfortunately, we have time only for one question for each team, so you have to, well, the first person wins, basically.
Yeah.
I don't know. It's not a question, but I like it a lot, your presentation.
Thank you. Thank you. I also like it.
Okay, do we have a question from the mentors?
That made me feel good.
If not, then thank you. Okay, so now I will ask five. Oh my gosh. I don't remember Greek alphabet, sorry. The second team, which is... No, I didn't. The second team, I see they know who they are. Thank you very much. The second team, so... The second team, Phi Eta T. Right. Here's your microphone and clicker. And as I said, the camera starts to have a range
How
here.
it works.
So, okay, and your
Just
presentation.
Right at left.
Okay. Hello, everyone.
1 second. Okay.
Oh, okay. We are going to present you our business idea, news platform on blockchain. So here we have a QR code where you can see quiz where you have 4 titles and only one it's true. The idea is in this day it's very hard to identify the fake news. So we are planning to make a platform where everything is verified, and using blockchain is also secured and no one can delete it. Okay. So, first of all, to use our platform and interact with it, you need to have a verified account. So, if you want to publish an article on our platform, you need to provide us some personal information like an ID card and a certificate, so we know that you are a real journalist. And if you want to be just a user, an ID card should be enough. Every article before being published on the blockchain must be reviewed by our team, so we know that it is valid. So, yeah. And of course, blockchain. So, when the article is published, it can be deleted. And if something happens, yeah, nobody can hide the information. We also plan to do a voting system for the users so that they can vote with up or down every article and decide if they find it interesting or not. They also can report the article as a fake news. And we are planning to do an ad-based ecosystem so that we are running ads on our platform, and the revenue from the ads will go to the users, journalists, and staff in the form of a cryptocurrency. And users also have the option to donate the money to journalists.
and the amount of money they receive will be proportional with the number of ads they interact with and how they vote for the users. And for the journalists, by the number of up and down votes they received on the articles. And also some money for us. We need to live.
Here you can see our career plans. I want to finish my studies and doing some thing with blockchain and IT. After my studies, I want to go to the industry and get some experience there. Simone want to finish her studies in medical physics and while doing image processing and machine learning, and that she want to do a research career. Varus also want to finish the study and then focus on PR advertisement. And Alexandru want to finish his study in physics and also do some economics, and after then he tried to do a scientific career, and then as young professionals. Our strengths of this project is that it's really, really hard to manipulate this blockchain. It's secure, global, so if you look on most of the websites like Google News, they just present that you want to see, and here you can see also what others see. And it's not controlled by a mandatory interest. So of course we have weakness. Until now we are just consuming and not providing news, and we have a high dependency on advertisement, and with this also the popularity, or better the other way around. If you have a high popularity, then it's easy to find advertisement partners. So our opportunities, it could be that we are welcome in politics because they have a feedback on their reaction, what they've said or done, and they see if it's affect the people, and the people are interested in unbiased votings and news. So of course we have threats. We have a huge competition because there are a lot of platforms providing news, and also we have to make sure that we are not entered by extremists. So here you can see the answer. It was a teenager that asked Elon Musk. So at the end, we provide you a test on menti.com. So if you like, you can go to the webpage, enter the code, and then we can see if you like this. So now I'm not able to understand what's shown here. I wanted to end this website. Left, middle, or right? Okay, enter. I trust you. So here you can see the first one. You see, okay, I don't know how many participate this code. So 2. Yes, of course. Sorry for that. 55929824. Okay, here, that seems not so interesting. Here, until this point, or probably nobody reached this point until now. It's not that interesting. And also this. Okay. Thank you.
Thank you. Thank you for your presentation. And now I will see if there is a question from the mentors. Is it a question? Yes.
Okay, my first question is, I have two. How you plan to overcome bias of the reviewers, and this whole reviewing process? How do you plan to organize this? And also, what is advantage to use blockchain here?
For the first question, the composition of the editorial board is very important for this. But of course, you cannot avoid a bias. That's definitely clear. And the second thing is we wanted to make sure that if one account is overtaken or something, that's or it's hacked, that's already stay the same. So it's more secure, or you can also look up what's happened in the past and see the history also.
Okay, thanks.
Okay, thank you once again, but just give me a second. I gather that you can just Okay, we'll go to the next team. Hopefully they will have a name that I recognize better. And now we have Sigma Rho Pi. Yeah, from
because of the camera.
From here.
Octavian, can you go?
And the clicker.
How do we use it? I haven't.
Sure. It's like
Okay,
this, and if you want.
thank you. So, may I start? So, hello everyone. Our presentation today, we try to tackle a topic which is fairly important in our world, mainly social division and the creation of the so-called social bubbles, especially amplified by the internet and by the algorithm, which feed people only with the news they want to hear, not with all kind of news, not with a general view of the world. As we want to start with a concrete example, here we have two plots with the political orientation in the United States, one in 2004 and one in 2015. And you can clearly see that the two bubbles are getting more and more disparate. That's something dangerous because it can lead to social alienation. People feel like they aren't.
So the people feel that they aren't connected anymore and they cannot talk to each other and keep in contact. So, well, the democracy is all about talking. So this is quite an important problem for all of us as a society as a whole. So how do we tackle it? Well, we know something about a complex system. We are physicists. And we can think about the bubbles in the network as an interacting system with some relations together. So here we can see Zakari's Karate Club model, which is a really simple one. We're the first. And it has some dynamics which is actually relevant. So in this experiment, there were there were a mentor in the Karate Club, and there was a manager. And they were in conflict. So the researchers drawn the connections between the participants of the club, and based on the connections, they could decide on the probability of given user participant being in one of the bubbles, we can say. So of course, this is a really simple model. There will be a lot of extension needed, and for that, we need to build our background and understand better the physics, the mathematics, the statistics behind that. So what will be the outcome of our work?
Yes, we divided it on a local and on a global level. And on a local level, there was a question how to there was a bias question in the last presentation. So we have an answer for this, a proposal that we can make an application that will indicate that a person has a confirmation bias. For example, if we say the person looked for read an article like for the fifth time in a day, or like in this particular time, there's gonna be a confirmation bias that will say, yeah, you probably may be too emotionally affected, and you have to look, you have to find to yourself back. So, and this, we hope that it's gonna raise an awareness of people.
Okay, for the global levels, we are expecting, since we are hoping that we can understand more better the relation between the social dynamics, and we will, since implementing the solution in global level is complex, we will use this understanding as an input, for example, in policy making or devising the education system that currently exists in our world. Now, in terms of careers, so for me, I'll be pivoting a little bit from optic to focus sociophysics and big data. And mainly the first step, we will be finishing the academics and hopefully make a connection to this main subject. And the next step will be basically also building the network to the main player of this big data and sociophysics.
Yes, I have a solid-state physics background, and I would stay in my master's in physics and would pursue the career of a theoretical solid-state physicist, and in particular in nonlinear dynamics. And I would take some courses in sociophysics and econophysics additionally, and I would visit conferences on this, and then I plan to do a PhD in, for example, University of Bremen on sociophysics, and research in academia in one of the universities. And of course, I'll try to be connected with the business, with startups, and if, for example, I'll have a dead end in research, I can find a startup or a company that is tackling this topic.
For me, I would like to stay in the solid-state physics, similarly to Anna, and continue the researching in this field. And I would like to stay there at least until PhD to get to know the field, to understand the possible methods, to understand the theory and how it works in the academic level. But also during the studies, I have some proposition for the universities. I would like to extend the courses to be more aware about the social issues, about how we can apply this to other areas. And after that, I want to use the experience to actually compare it, how it will look like with the data giants such as Meta or such as Twitter, which we will probably need to work with during the project, because it's all about the data.
Thank you. I have an interest in neurophysics and neuroscience, and in order to pursue our goal, I'll have to make a master's degree in this field, and also to take on supplementary courses in things like natural language processing or machine learning, artificial intelligence. And after that, I will probably go to a company, maybe found my own startup, in order to better learn how to get funding, how to cooperate with politicians, with other scientists, other professionals in this field, which are all skills we are probably going to use in our plan. And now we have a SWOT analysis of our project, as our main strength is the diversity of our team. We come from 4 different countries, we have different backgrounds, and therefore we have a much broader view about what we can do, about what our skills are. And I think our problem-solving capabilities are extremely broad from what I've seen in these 2 days. And as our main weakness is our lack of experience in social sciences. Like, we all have physics backgrounds, we don't really know a lot of psychology, sociology, and we will have to learn more about this in order to pursue our goal.
And both our opportunities and threats come from this, from how big this project is. So because of that, we can get the funding from big organizations such as European Union, and we can network with existing researchers. But also, when dealing with such a big project without the experience, we may end up in having troubles with commitment and motivation towards finishing this project. So this is something that we need to work, and I think that we will work together and we'll be probably meeting annually on the science, social physics conferences. So see you there.
And thank you for the attention and for the guidance.
It was really helpful. Thank you.
Thank you very much. And now we have a time for a question from the mentors. Oh, I see. I didn't thought it through, but I see that Piotr will save us again, like with the lecture. Yeah, maybe we'll just stand next time next to you. And
No, I promise that I will try to make it my last question during this session. But what? Yeah, it's my topic, so I save. So I'm interested. Why did you choose the University of Bremen?
I was just searching for social physics in Germany, since I live in Germany, and this was the first article I read about social physics research, and then I was just on the website of Bremen, and it was looking really interesting what the researchers and the professors did, and also the different papers they published, and it was one of the possible way for me to pursue.
Okay. You may also regard this Jakobs University in Bremen, the same city. Now some Russian oligarch bought this and is planning to transform it to some kind of AI-driven university and technological hub. So they will do plenty of data mining, AI networks, and stuff like this probably can be applied to social physics also.
Okay.
Yeah, I know that this Russian oligarch thing is a bit sloppy these times, but
maybe it was I was just researching quickly just to look for what kind of possibilities I have, and I didn't know about the Bremen University.
Okay, thanks.
thank you. Yeah, I have to say that that university bought by Russian oligarch to use AI and data mining sounds very promising. Thank you. Sorry, it's a bit chaotic to do all of that. Okay. So. So now, if I can ask omega eta nu, I guess? Sorry about that. Okay.
Does this work?
Here you have the switch on
So before I start, I have a quick question to you. Like, how many of you know what type of battery is used in your phones? Okay, so the main currently the most used battery is lithium-ion battery, which has cobalt in it because it's based on lithium metal oxygen battery. And well, cobalt currently is produced mainly, like the two biggest producers is the Democratic Republic of Congo and Russia, which are not very good partners economically for us. So we came up with this idea of creating, like using a different type of battery for mass production, and that will be used because batteries are very important in our lives, and they will become even more because they are basis of our energy systems for like storing energy, and also our transportation. The electric cars use it, and of course we use it in our everyday lives. So the problem with lithium, when we came up with the idea of replacing lithium-ion batteries, which contain cobalt, with sulfur instead of cobalt. So we would use lithium-sulfur batteries. The problem with lithium-sulfur batteries is that they have actually higher energy capacity than lithium-ion batteries, but their current life cycles is short actually, and we would plan to develop that. And also on mass production, there comes problems with the sulfur, because sulfur, we currently extract sulfur like as a byproduct from fossil fuel, and to produce it on a large scale, during the extraction we would emit quite a lot of acid, and the solution to this might be a bacteria that eats acid, and that's our plan, what we are trying to do. So I think I will go to our career. So Katrin will start first.
Okay, so I will focus on my master's on biophysics, and I will really focus, because I have a background in only physics, I will focus on the biological and chemical part, and after that I will gain maybe more knowledge with an internship and trainee program, and then probably go to, at some point, to a Max Planck Institute for bioengineering or something like that, because they are working on similar things, and I would then help producing these bacteria that eat this sulfuric acid.
I have a background in experimental solid state physics. So first of all, I will recognize the experimental methods of making lithium batteries with sulfur. I will get the financial support from Polish government to visit scientific centers which actually work with this type of batteries. And after I finish my PhD, I will go to the postdoc position job to selected center, and after that I will create my own group, and we will invent new ideas for this kind of batteries.
And I will start studying automation engineering in order to start mass production of lithium sulfur batteries, because currently lithium sulfur batteries exist, but they are not used on commercial scale and not produced on commercial scale. And I would it would be a challenge for me to overcome and start this production in order to in future make those lithium sulfur batteries cheaper, and it will give me the opportunity to get better at optimizing things and optimizing production. And for the financing, there are quite a lot of plenty grants that we can get. For example, from the on the left from American, but also on the right from European Union, because governments are looking for new types of batteries too, because of the climate change, and to also the scarcity of our resources. So our strengths would be that we would use more like common material because sulfur is way more common than cobalt. We would also like cover many expertises because our team would be quite diverse, and the basic like knowledge already exists. We would get the basic knowledge about lithium sulfur batteries during our studies, and that's a starting point to develop it. But our weakness is that lots of money is required, which we don't have, and the technology is not established enough yet for the mass production, so you'd have to work on that. And there's also highly competitive environment because there are already grants, so and there are already other teams working on different type of batteries, also lithium sulfur batteries. And our opportunities, there are plenty of investors that would be interested in us because of like rising prices of cobalt. That also we would get support from different branches of industry because it would create like more supply chain because we would have to like extract the sulfur also, and also later on like the recycling. And thus we would create a lot of different professions, which is also like something good for the investors, like especially for their governments. But like the threats that working with the dangerous chemicals, sulfur, that could be a problem, could give us like a lot of problems like there later on, and also environmental laws of countries. That could be a problem for when we plan the extraction of sulfur, and that would be everything. Thank you.
Thank you. Okay, so do we have a question from mentors? I mean, okay, I see.
So this is you concentrate on one element, and don't you consider that there's a threat that there will be like emerging technology that will render these cobalt batteries, obsolete?
Yeah, I mean, there are also other type of batteries we would have to like compete with, and that's also like a problem that I think we still can like overcome, because I see like potential in lithium sulfur batteries still because of the higher capacity, which that can like really like place the lithium ion batteries which are currently used, but that's also like a threat to our company.
Thank you.
Thank you. Okay. So now we will have mu delta kappa.
So our team was concerned with the extreme climate crisis and its possible solution, closed ecosystems. So first, let's look at why. Why do we even care about climate change? Well, we care about it because it affects our lives. We care about saving and hopefully improving lives and preserving the biosphere. So if this is our goal, then maybe we should focus on maximizing the expected value in relationship to this goal. But how do we do that? Well, one possible good solution would be to focus on the extreme outcomes. Many people focus on maybe 1 to 2 degrees of warming, but there's a real possibility of about 10 degrees of warming in the next few hundred years. And even if those extreme outcomes had a really low probability, if they resulted in an existential catastrophe, then the expected value would be so high that it's still a threat worth preventing and researching. So how do we do that? First thing would be prevention and the research. We would need to do research to know how to actually what will actually the causes be, how the extreme scenarios will look like, how severe it would be, when will it occur, and there are also many unknown factors that will hopefully become known during the research. But if the scenario is inevitable, we'll need to adapt to it. And for that, we came up with the concept of closed ecosystems. Those are self-sufficient environments in which that we could build either on Earth or in space, where we could hide people, animals, and plants to live when the Earth becomes inhabitable. There were in the past some projects like Biosphere 2.0 that we can build upon. So our concrete career path. I will be focusing on the modeling, on investigate the extreme climate scenarios, how likely they are, and what to do about them. But this is also crucial for the closed ecosystems because we need to know how exactly the extreme scenarios would look like so that we can know where the ecosystems should be built and what they need to withstand. So in the next 3 years, I would be focusing on getting basic knowledge, getting masters in mathematical modeling, but then also do internships and master's thesis in cooperation with the climate department of my faculty to get some basic knowledge. And further, I would leverage this knowledge, get a PhD at the Center for the Study of Existential Risk at Cambridge, and I could use that knowledge to fund a startup concerning this problem. And with that, I would like to get help of several companies like the Founders Pledge that could connect me with experienced people that could help me, and the charity entrepreneurship that focuses on giving grants to and incubating new charities with meaningful goals. Rafael will be focusing on the energy supply. So far it was only in photovoltaics, but that might not be really suitable in case of a global crisis. So the solution could be thermonuclear fusion. And Rafael will be concerned with the managing of plasma flow. He will take a PhD in the controlling of turbulent plasma flow, and then after his PhD, hopefully the ITER will be finished, and there he can gain experience working in the largest thermonuclear reactor, and for the development of the reactors to know how to use them in the closed ecosystems. Zuzia will focus on the source of nitrogen, which is crucial because nitrogen is needed to grow any plants. So, and the main source of nitrogen in these closed ecosystems will probably be urine. And she will use bacteria and bioreactors to obtain it. She will pursue an internship in Melissa Foundation of the European Space Agency, and then a PhD in Belgium Nuclear Research Center for UNIUS project, where she will also gain further experience with bioreactors. Zosia will focus on the monitoring and controlling the internal conditions of the whole system using drones that can control, for example, thermal maps, the growth of plants, and many other things using the BVLOS technology. And after finishing her bachelor's, she will gain experience with creating drones in the Dorianda annual competition, and then work full-time at Flytronic on building and improving drones. Now, the four of us probably can't do this whole research of closed ecosystems by ourselves, but many other aspects of the research will need to be solved. Some of them are written here. And for that, we will need a collaboration with other scientists in various fields all around the world. Now, you may think that we are focusing on only the extreme case scenario, so what if the catastrophe doesn't happen? Well, in that case, our research will not be wasted, because our research will be applicable to many other sciences. For example, the closed ecosystems, we can use that for space colonization or preserving biodiversity even if a catastrophe doesn't happen. we will, or other offshores will be improving climate models, wild habitat management, waste management, and so on. So to summarize, our strengths, as I was saying, will be the applicability of our research, even in the case that crisis will not happen. We have a clear career path to obtain it. We have an opportunity because the area is not very crowded, but it is still really important. But our weaknesses include, as I was saying, we'll need to cooperate on large scale with many other scientists, and the time scales are unsure at this point. So to conclude, we have a crucial problem, the extreme risks of climate change that could pose an existential risk to humanity. We have a possible solution to closed ecosystems and a specific career path to, that we can use to dedicate our lives to the pursuing of this worthy goal. Thank you for your attention.
Thank you. And now we will see if there is a question from mentors. Okay.
So you mentioned that you are going to found a startup after PhD. Do you have any idea what the startup is about?
Yeah, I mentioned that as a possibility that I could leverage my knowledge gained from PhD. I could either pursue a path in academia further, or I could fund a startup. And well, yes, the startup, there are two ideas for it. One of them would be directly focus on research about everything I was saying about, or like the research in effects of and strategies for the extreme climate conditions, which could be in cooperation with other startups and companies like the Center for the Existential Risks. And the other idea is that it would be directly about creating this project of closed ecosystems and directly building it.
Okay, thank you.
Thank you once again. Okay, so now we will have presentation from, yes, exactly, from the team number 6. Yes. Oh, sorry, wrong mic. Okay. That's mine.
Hello. Oh, this is okay. Okay. How to say it?
The camera runs.
Yeah, it's this is the, because how yes. Okay. Hi, this is our team. We try to find a solution to improve the way of recycling metals, and we thinking how we can improve our environment and make it cleaner. And we decide that by now there is a huge production about solar panels, battery, but there isn't still any method to recycling this. And we try to find something which also will be eco and do not waste like world resources. And we decide for recycling materials about using bacteria. Also like the huge problem in UE is that by now we don't have any system to recycle this material from panel solars, etc. And we import this material to different countries, like we can see. None of them are in Europe. And because of that, we lose a lot of money. And also, in like crisis situation, we will be depending on them. And after using our idea, and we will have a possibility to improve our environment and also like be able to do this by ourselves. Oh, okay. Something goes wrong. And next, our solution for this problem is bacteria, like we said. We find that already in our ecosystem exist bacteria who can take it out the pollution from metals and other materials, and we like to use the metabolism path that this bacteria use, and also catalyzation this process to make it faster. Yes, and next, and we would like to improve this process by starting with our education. For example, for me, it will be finishing my master degree in Politechnika Wrocławska at the biomedical engineering field. After this, I decided that I would like to join to OBER internship group, which provide me like the possibility to make a research about bacteria and metabolism. And next, I decided to start working in brand new company near to Wrocław, which tried to struggle with the problem of recycling bacteria. The career for Maurice, who he chose to improve our researches, is to go to the Germany university and study chemical physics to improve our catalyzation process, and next go to Netherlands University and from there start internship connected with this university and also connected with organic chemical in industry to improve our industrial production of our new recycling system. And Asia decided to finish her master degree in biophysics and next joined to PhD study in Polish and joined the Necki Institute group, where she will learn more about metabolism. And after this, she liked to improve her soft skill in MBA Academy, which also help us with providing with all our idea to start the company next. And this is our SWOT analysis with our idea. Our strengths are that we check that there is a possibility to use this bacteria because they already exist in our ecosystem and they do this. And we know that if we research more in this topic, we will be able to find the solution and increase the speed of this biorecycle process. Our weakness are that the topic is very popular and there is a lot of research around this, and also they probably will be huge cost of chemicals that we probably use in catalyzation process, but we will also try to avoid this by taking the study and also participate in some internship to see how other companies overcome this struggle. And our opportunity is in next year, Polish government require from all companies to recycle their products. And we think that this is a great opportunity for us because we will be able to provide this process for them. And our weakness is that there is a lot of research on this topic, but we think that our field of study is quite wide, and we will be able to cover more than one materials by using this bacteria, which gives us opportunity to help to be the main resources of this process. And after all our education path, we decide that it will be great if we will be able to cooperate together and create something together. And we think that this cooperation should start at the university where we get our education. And this will be a great place for us to find a place for research and starts inventing the process. Next, we think that we will try to find financial support using European concourse or national organization. And next, we would like to commercialize our idea by searching partners and also maybe patenting our production process. And the last step, hopefully, this is our dream, that we will be able to start our company Solar Curious, and here you can find our logo. And here, we hope this is our future. Thank you.
Good job.
Thank you for the great presentation. And as usual, does any of the mentors have a question? Okay, I think that's something that we can improve in the next edition, because I think that that mentors ask most of the questions. Yeah, maybe some other teams have a question.
Why now?
Let's make it harder.
Great.
Okay. Well, in this case, I think you're spared a question.
Okay.
Thank you.
Thank you.
And now, if I can ask for the team Zeta Eta.
Okay. Can you hear me? Yeah, I can hear myself. Okay. So, we are the team Zeta Eta, and we would like to introduce you our project, Decluttering the Earth's Orbit, the Problem of Space Debris. So what's the problem with space debris? Well, basically, people leave a lot of non-functional artificial objects in space. That's the problem. First attempts to limit the growth of the amount of debris was in the 1970s, when NASA tried to set some limit on the growth. But currently there are approximately 200 million pieces of the size of 1 millimeter or greater, and also approximately 6,500 tons of material up there. So that poses a serious threat for our infrastructure in space, like for our active satellites and spacecrafts. We rely on GPS. We rely on satellites for GPS and also maps and weather forecasts. And maybe in a few years we will rely on satellite-provided internet. Also, it's a problem for observation and measurement because the debris is actually visible in photos. So there are two ways to tackle the problem. First is to mitigate the growth, and the second is to eliminate the existing debris. We chose the second one. Fortunately, we are not the only one who chose this problem. There are already some companies that want to tackle the problem also, so we would like to join them. For example, the Clean Space Project, which is supported by the European Commission. Another European project is the Clear Space Project of EPFL. And also another project in America, like the NASA Orbital Debris Program and US Strategic Command. So, how do we actually want to tackle the problem of eliminating the debris from our orbit?
Okay, so a major problem is the detection, and we thought about mapping Earth's orbit. We have to take into consideration multiple factors, like the shape of the Earth, kinematics of the lower orbit space debris. So in order to counteract the detection problem, we need to build a system of radio telescopes as receivers and radar beams around the world, which can effectively scan the entire lower orbit in real time. As a general rule, radars are primarily used for the characterization of the space debris population in LEO. The radar beam is pointing to a predetermined position in space, and after detection, the object is tracked
and observation vectors are collected so that the orbital parameters can be computed. And also, we need to construct an appropriate software to process and visualize the data.
Okay, so the second solution is developing a net on the LEO. So it can capture small and medium pieces of debris. So a device could be possibly made of ballistic gel, so it will be resistible enough and flexible enough, and the components wouldn't be destroyed during the process. So its aim is to have an opposite thrust vector to the debris, so it captures those pieces and put them in a state of zero kinetic energy, what makes them fall down and to the atmosphere and get burned down.
So the third method of getting rid of debris is the so-called laser debris removal, which includes a ground-based laser, which is targeting potential hazardous small to medium-sized objects after, of course, implementing a successful surveillance system for those objects. They can target these satellites and bring them down by applying a force to them, which is caused by an exhaust. So they are modified in their trajectory and eventually and hopefully put down to the atmosphere where they get burned and safely destroyed. So, yeah.
Now, the possible careers we thought about. After I finish my bachelor in physics, which has a general approach, I will possibly I can do a master's and a PhD in astrophysics, focusing on radio telescopes and radio astronomy.
Yeah, I will too pursue probably a bachelor's degree in physics, which is followed by a master's and PhD in quantum engineering, specifying the research on materials that could potentially enable such methods like a net that can actually catch those large objects, and later going on maybe on mechanical engineering.
So the third proposition was to complete a bachelor in optics and photonics and do a master and PhD in optoelectronics, and maybe then join a space company to work on lasers, telescopes, electronics, and gain experience.
And my possible career path is finishing, hopefully, a bachelor in mathematics and informatics, then get some master or perhaps PhD in data analysis and programming. And then I would like to work on the detecting system software, which we were talking about, and the data processing and also the visualization of them. So.
Yes. Lastly, we have the SWOT analysis, right? Beginning with the strength. So first of all, it is a severe problem for all of space agencies. So we have the whole planet on our side if we want to continue this pursuit of space travel and maybe commercializing space. Then we have the possible innovational solutions, which we still don't know yet, because as the threat rises, we enable a lot of new ideas by these means. We can collect new data that we still don't know yet by means that we still maybe have to develop. And then protecting satellites in space is a priority for all of agencies. The weaknesses are, of course, first of all, the simulation of all the systems. Targeting small objects in space with precise lasers is very difficult. It is time-consuming to develop, just looking at James Webb, for example. And the realization of this is really difficult, as I said. But the opportunities are, in contrast, the international interest of all countries who want to pursue the space travel, for example, and the attention and funding of these agencies, and making overall space more accessible for the future. The threats, unfortunately, are, of course, the military abuse of those lasers and the accidents, in case they occur, that can cause even more debris than expected. Which concludes our presentation. Thank you.
Thank you very much. And as usual, is there a question from mentors or the public? Oh, great.
I know nothing about the topic, so I asked the question to understand it correctly. So what is the size of the object that you would like to hit with the laser?
So as I said, it's usually small to medium-sized objects. Of course, they have some sort of kinetic energy. They rotate, for example, older satellites are in this case. So the sizes usually vary from really small, as we said, from 1 millimeter, which can be detected actually, to even sizes to buzzes, which functionally need to be kind of netted around with a net or other means.
So, but let's make it precise the scales from 1 millimeter to up to?
Up to whole bus.
The whole bus, okay. So my question is it even possible to hit anything with this and you have atmospheric scattering of the laser on the way?
Ground-based do indeed have this weakness, which can be countered by, again, more precision in the future, more powerful lasers, and of course research that needs to be done in this field. As for now, we still maybe are looking at mere results like coin-sized objects that can be maybe altered in trajectory, but for now we're not sure.
Also, partly it's the question of the detecting systems, because if we can detect it and measure it better where it is actually, then we can better shoot the laser in the right direction on it. So there's also the question of the detection system.
Okay, thanks.
Okay, thank you once again. Okay. Okay, if I can ask the team Delta Gamma.
Do you want to take it? Oh, okay. So, hello everyone. We took upon a very kind of trendy subject, and I think one that many people are fascinated about, which is how to get to Mars and how to even start this whole process. So one of the challenges in space exploration is that spaceships mostly, most of the mass that they can take is the fuel. And we can't take many things that we would need with us on a different planet to build habitats or to expand a long-term settlement. So the solution for that is to acquire resources directly on Mars. And our project is to design a rover which would do large area spectroscopic measurements to identify locations of materials that will be later used to build settlements by people who come later.
Of course, we have some problems to solve. This is our purpose. The first one is the lack of knowledge of precise location of the material we need to build the hubs or another things. The second one should be the slow communication between the rover in general. I'm talking about the actual time when you have the distance between the Earth and Mars, so you have a time lost there. And the third one should be the low speed of rovers, because you have to cut a lot of energy because you don't know how long can you use the solar panels. And of course, we have the solutions. The first one should be improving spectroscopic technologies. And this way you should know where it's the material you need to build. Let's say titanium, aluminum, iron, anything. And the second is establishing communication with the rover for navigation and commands. So you should have many satellites and artificial intelligence. And the third, for the energy problem, developing a durable and high energy storage nuclear battery. So basically you wouldn't need those panels. So.
Okay, and we planned our career paths around it. So I'm doing masters in optics, so I would deal with the spectroscopy part of things. And as the first step after I finish my masters, let's say this summer, I would go to European Space Agency to, I found some internship where I could evaluate the most effective analytical methods for mineral identification. And then I would go to US to do my PhD in applied physics laboratory at Johns Hopkins University, because there are people who already work on spectroscopic devices which are sent to Mars. And at the same time, I would join Society for Applied Spectroscopy to network with other scientists, find people who could help me and get the knowledge I need from them. And then after I do my PhD, hopefully I could work on developing this like a new spectroscopy technique or improving existing one at the NASA Jet Propulsion Laboratory, and to then my technique would be used in the rover.
So, so my career path starts at 2022. I'm going to make a bachelor degree and master's degree on MIT in the US. Then in 2027, I'm going to leave the academia and start working on AI problems in Intel, and then in ICO, the Italian company which specializes in combination of AI and satellites. Then I'm going back to academia and start my PhD also on MIT to combine knowledge from academia and industry and to find new solutions to the problem of command chain. And I'm going to do this on the aeronautics and astronautics faculty. On 2032, I'm going to work in NASA's Jet Propulsion Laboratory to develop ideas in the combination of the rover and drones and the satellite swarms.
My career plan, first I'm gonna finish my bachelor's degree in Bucharest. In the same time, I'm planning to have an internship at the National Institute of Nuclear Physics. Then the most and the goodest choice I could have made is to get a master's at the University of Houston. There is the highest, let's say, institute that knows about nuclear batteries. In the same time, of course, I want to have an internship, and then at the PhD I should work for them, and then could also go to NASA's project and work with my colleagues.
Okay, so now let's go to our SWOT analysis. So first of all, our strength is that this is a very innovative technology, and it's a potential to conduct research on Mars on a large scale and find out what actually there is, what we could use. And also maybe there will be some new unexpected discoveries made on the way. And this technology, because we cover so many different things, could also, there could be found some different applications of the system developed, the AI or the nuclear battery for sure as well. And yes, and in the end, our project aims to increase likelihood of successful long-term settlement of humans on Mars, because they need to be self-sufficient if they're gonna stay there for long. The weakness is, of course, high cost, because especially I think with developing the nuclear battery, it seems like maybe something that would require lots of funding, and yeah, it could potentially be difficult, and so yeah, also high chance of failure, as comes with any innovative approaches. There's always high chance of failure, and the complexity. There are lots of things that can go wrong, and probably lots of people that would have to contribute to this project. And yeah, the opportunities is that things to do with Mars usually are quite trendy, so could be interest of public opinion. Maybe we could organize some, I don't know, crowdfunding for part of the project, even, yeah, something like that. And governments sometimes maybe also want to use in their political play that, I don't know, they want to send people to Mars and look how great we are. And that are the opportunities that we see. And the threat is that someone else will come up with this, with those ideas before us, and that maybe the funding will end after some time and we won't manage to develop the project fully yet. So thank you for your attention.
Thank you. Okay, so do we have a question from mentors? Great.
Firstly, a comment. Congratulations that you selected on a space exploration. I think it's a very challenging topic, and usually people withdraw from it because people think it's a waste of money, waste of time to go to space and explore, so congrats. Second thing is that you concentrated a lot on the USA, collaboration with USA and so on. Is there any reason for it? We also have a huge heritage in Europe on rovers. Wouldn't you prefer to stay here in Europe and develop on this background?
I don't know. I'm not sure. What I know is that when I was researching this topic and the career paths, I just found the opportunities, for example, at this Johns Hopkins University with the spectroscopy measurements. And yeah, and we didn't really have enough time to consider all the factors, but it just seems like US is this, like, in some way it's like this American dream that every crazy idea can come true, so maybe that's why we kind of followed this path, yeah.
Thank you once again. Sorry for that. Okay, so now we can welcome the team Beta Alpha.
Hello everyone, we are group Beta Alpha, and our project is asteroid mining and building a space industry.
Thank you. Our purpose is to build a space industry by mining asteroids in space. The problem we identify right now with space exploration is that we pay a lot to bring materials from Earth to space. And we want to reduce the cost of space exploration in general by producing materials in space from resources collected from space, namely from asteroids, and also by controlling this from Earth. So we want to control this space exploration through robots. This is totally feasible right now. There are experiments in progress, and there are also theoretical studies related to asteroids in this field. In the next, 100 years, I think Earth will be surrounded by a space industry. We want just to make the first step right now. Why do we want to do this? First of all, people is gaining confidence in this. You can find here 2 articles from Bloomberg, 1 year difference between them and a totally different title. Our problem, as we stated, is that we need to reduce our costs. And this cost can be reduced in 2 directions. For example, metals require to build different things that we can build in space as well as on Earth, and also fuel, which is basically can be obtained from ice, because ice is water, hydrogen plus oxygen, and these are the components of rocket fuel as we know it right now. There is a lot of mining potential around Earth. First of all, this is a graph of near-Earth asteroids discovered as of yesterday, and you can see there are lots of big asteroids that we can mine. Also, on asteroids, we can find different kinds of metal in more higher concentration than here on Earth. You can find the things that we need for fuel, for, I don't know, building stuff, and also for, we also can find rare materials. And we need, in this purpose, to get exactly the right asteroid, because these asteroids are very different one from another, and we need a thorough research to know exactly what asteroids we want to mine for a certain purpose. Our technical operation basically begins by building an orbital facility capable of mining the resources and also produce the stuff we need for building everything we want. Then we want to capture near-Earth asteroids. We require techniques such as propulsion or gravitational slingshots. We've got many techniques. Then we extract the useful materials. It depends from case to case. We need a certain purpose, and this will require energy, which will be solar and nuclear. Then, of course, we use these components to produce the things we want. The time horizon for this operation is like 10 to 15 years for the beginnings. The costs are a big problem. An estimation from Caltech puts them at $2.6 billion. But if you want to expand this industry, you can spend up to $100 billion. However, the money saved not to bring stuff from Earth to space is definitely higher. A football terrain-sized asteroid can bring up to $50 billion, for example, if it's made out of platinum that we can find in the asteroids. Right now, we will present the career paths that will lead us there. And Dominic, please present.
Thank you. So I'm Dominic. I have bachelor degree in mathematics and hope soon in master in physics. I want to focus after this on astrodynamics to reduce cost of reaching those asteroids and bringing them back. Especially, I want to focus on the low-thrust transfer problems, changing orbits of objects with a low thrust, for example, with use of solar sails. There are also research right now on the European Space Operations Center in Germany. There are many positions for postdocs there, and I hope it will be useful for this project. So, Lydia?
My field is nanoengineering, and I know that nanotechnologies is very useful for developing space. And nanotechnologies can be useful by spectroscopy, by production energy, and radiation protection. It motivated me for developing new materials, equipment, and techniques.
Thank you. I want to manage this project by choosing precisely the right asteroids, and this is why I pursue studies in physics combined with astronomy and planetology that would lead me to identify the most important asteroids, the most feasible options for our project, and also we want to make an initiative of mapping the asteroids around Earth, because we don't have that much information about them because we've basically concentrated on the main belt. We want to find some partners in this project, and we have research partners, investors, and clients. The research partners are basically universities, research institutes, and space industry actors. You can see that they are already highly involved in asteroid mining. And also there are lots of people who want to invest in this, starting from particular investors who already spent a lot of their money on space, like Elon Musk. We also have high-risk or venture investors who invested a lot in space mining, and we think we can pick up the pace and gain their support. Also, we have an already existing clientele because we can sell our products to national and private space agencies wanting to launch deep space mission from space to save money, and also to companies who want to set up equipment in space, for example, satellites. Our SWOT analysis is consisting of several unique strengths, I'd like to say. We have fast access to rare materials that we proliferate in space by controlling everything on Earth through robots. We have lots of opportunities, namely near-Earth asteroids, so we don't have to go very far to capture an asteroid. We don't have to bring it from the main belt. And also, space industry is expanding. We will find clients for our products. The main weakness we have is related to the many steps we need to take. There are lots of steps and every one of them has a high cost. However, we have a solution for this. We want to plan ahead and secure funding and also get profitable as soon as possible. The main threat we encounter is that we do not have enough information on NEAs, or the near-Earth asteroid, but we want to compensate this by thorough research. So far, we know these asteroids came from the main belt, but we want to know how similar, if they are equally distributed as in the main belt. This will be the purposes of our research. Also, in order to gain more experience in the private sector, we plan on working for a few years in this sector before actually starting our own company to gain working experience in this sector apart from the scientific expertise. Thank you very much.
Thank you for your presentations. And do we have a question? Mentor, I will ask if the mentors have a question first. I see you, but okay, no one? If not, then I will get there.
So some of the data uses from planetary resources and I think deep core or deep space industries, something like that. Main point is companies have tried this before and failed before they reached profitability, also with a plan of selling water. What do you think has improved in the world or has improved in your way of doing this that will make you succeed where they failed?
The main thing that improved is that we are at the right timing. We've got plenty of information right now about this object in terms of size distribution. And also we are at the point when we can become profitable very fast. There will appear new infrastructure around Earth. Think only of NASA's Lunar Gateway that will act as a first spatial hub and is already included in the Artemis program. This kind of hub will be useful to ship material from moon to space, to store material before using it. And this kind of stuff will certainly expand, and we can use it to build a real industry, because so far there has not been a correlation between mining and industry. We want to make these things simultaneously because we think they are deeply correlated. We can't do one without another, and this is exactly what you told me.
Okay, thank you. Thank you once again to all the teams for your work during this 24 hours, thank you, and for beautiful presentations right now. Basically what we will do now, the mentors have a half-hour break to deliberate and discuss and count the points and come up with the results of which team will be winning, I mean which 3 teams will be winning. And we will have a 10-minute break, and in 10 minutes I would like to see you back here, because we still have one more thing for you. Okay, so that's a break time. now, a little bit of repetition, but you know how it is. So as we are basically finishing right now this whole event, I really wanted to say thank you to all of our patrons, which is the AGH University of Science and Technology in Krakow, Wrocław University of Science and Technology in Wrocław, Polish Space Agency, and University of Warsaw. Our strategic partner was Faculty of Fundamental Problems of Technology from Wrocław University of Science and Technology, and our host for this whole event was European Center of Geological Education and the Faculty of Physics of University of Warsaw. The whole event is possible because the Ministry of Education gave us a huge grant. You can even see exactly how big and how much of our own money we used and how much was of the Ministry of Education. And we, of course, very grateful for the Ministry of Education to fund our initiatives. And now we have something new, something very special for you, because as I said at the beginning, we had one group that was taking part in the marathon, but they're not participants, they're observers, or specifically, there are two representatives of the executive committee of the International Association of Physics Students, which is Cyrus Walter and Arnold Nielsen. And our two special guests from the Scalp Robotic Association in Gdańsk, which is Mateusz Dyrda and Marek Winczewski. They observed both how the mentors worked and how participants worked and worked themselves at the same time. And now you can see what they came up with. So come here.
You find a presentation?
You can just give me the clicker once.
You have the clicker?
You can just give it to me when I go into my part.
Clicker how? Clicker right? Clicker left?
Oh.
Hi. I hope this works. I think so. At least people staring at me. So, yes, as you noticed, we sat around for a while, and we noticed, after talking to mentors, talking to you, looking around a little bit, that there's one specific question we should actually ask ourselves a little bit, which is, why? Why are we here? So, ScienCon, what for? So, question why? Why are you here? Come on, guys, I need your help for this presentation. Why are you here? Okay, so why then? We are pretty sure, no, we actually don't really know. So our question is, what do we have to do to die as happy physicists in the end? To be happy dead physicists. Our idea is how to tackle the challenges that appear on your road as a physicist. Because the whole idea is, all you had to do is planning your career path for organizing, you wanted to organize a specific project, and for that you want to have a specific career path. So we're going through a little bit of career paths you can actually take and what you have to do to really achieve them. So that's where you are right now. That's the start. Oh, most of you. There are a lot of people, and actually everybody is just running to the same direction. You just go ahead, but no one really has a direction.
Yeah, so we're not assuming a lot about you in this. We're assuming that you're a fairly average young physicist. Some of the things we're going to go into will be more or less likely. We've seen a lot of internships at Stansted and NASA and other things in your presentations, and that's also sort of the approach we're taking, but usually with a safety net. You can just go, yeah. So we all have a general education. We're all, and that can come us to benefit in a lot of cases where we might not need our physics skills, but might need other things. A lot of these things are kind of weird, but something that you should, as normal students, be able to do at least in theory. We have a lot of motivation, we have some mental health, and since we chose physics, we probably also have some absence of mental health. At least we'll get it soon enough. From these things, we'll see how we can develop in these more or less strange ways. And the first one is Cyrus's idea.
Okay, so it's actually what kind of I want to do, so bear with me for a second. We'll try to get you there. Let's talk communication. So I'm looking at a physicist that ends up in communication and decision making. So the end of the road, remember, we want to be a dead physicist in the end? A science communicator who nudged humanity off in a good direction. Depending on what good is, depends on you. So we're talking governments. Anyone does not know who that is? Okay, good. That is Angie. Angie was a chancellor of Germany some time ago. She did some good things. Pretty famous girl. Does anyone not know who that is? If you're not lifting your hand, if you really don't know who that is, I'll just pick people and ask them what this person is. Okay, so that's Neil deGrasse Tyson. He's a TV moderator, and he writes some books. And he's pretty good in that. We're talking that guy. Do you know who that is? Who does not know who that is? Okay, I'll tell you who that is. That's Rolf Dieter Hoyer. He's right now the chief scientific advisor of the European Commission. He has been CERN director for a while, DPG director for a while. Essentially, he had all important positions in his life already. So he will probably die as a very happy physicist. Which guy? Does anyone know in this room who that is? Jihad, who is that? That suits pretty well. No. I hope so, because that's Michel Spiro. Michel Spiro is the president of the worldwide biggest physics union, and he's also the chair of the International Year of Sciences for Sustainable Development. That guy is connected with everybody and has way too much power a man should have. So what are these skills you need to go that path? You probably need, as a science communicator, some presentation skills. I think so, maybe some. Some charisma, for sure. Some expertise. You have to stay open-minded, so you don't close yourself up too much. Isolation is very dangerous, as we learned in the last few years. Broad basic knowledge, and a little bit of acceptance of everything. Talking about decision makers, what do you need? Courageousness, a will to take risks, not jumping from the building, but taking some risks. Open-mindedness, of course. Some strategic overview, what's going on around in your company, in your association, in the European Union maybe, depending where you end up. Some network center, being essentially the network center itself. And so a little bit of social analysis, because we A, assume that we can notch off humanity in a better direction, and B, that we all sociopaths. So one way of many is I'm presenting you with that guy. Remember that one? And we want to achieve through academia that guy. So let's see how far we can get. So first you need to, if you want to reach this, you should pursue your studies. You wonder why. Communication has nothing to do with physics. It does. So you pursue your studies, you should visit conferences, because then you participate, you practice your presentation skills. If you participate, you stay open-minded, listen to others. You also get to know relevant people, a lot of relevant people, as you all are, and as I got to know you, all of you here. Develop in specific expertise. You should, when you, not on conferences, you should develop a specific expertise that's essentially useful to everybody. Like fixing climate change. That would be good, wouldn't it be? Discover physics and discover the way a physicist analyzes things. That's very important. Next, you need to initiate social contact with everybody. And I mean everybody. Improve your appearance everywhere. Learn to be charismatic. Connect to people. Develop the way of how a physicist analyzes and use it for almost everything in society. Understand people, become the network of the center of all networks, become unreplaceable, and maximize the happiness of everybody. Collect, and lastly, collect relevant experience. So set high goals, standards to yourself, always take the risk, because, I mean, you fail, but you learn out of it, right? Volunteer in associations, clubs, unions, take over positions because you can practice. Learn from the people that are old, that have the skill, and take over their career jobs. And lastly, develop courage, so you end up having achieved a happy dead physicist life. So, and what you ask, what do I do if I have checked all these boxes? Take a deep breath, evaluate, repeat the whole cycle, study again. Obama thinks this as well. Thank you.
Okay, yeah. So originally we were going to have two extra, we still have two extra presentations, but we were going to have both a presentation on an academic career and a career in industry. The academic career sadly was cancelled, so that means we're just learning to make money today. But hopefully that'll be fine. And I do think this is an important topic because I think quite often we can start thinking about going into industry like we think of death. We're all going to do it someday, so there's no need in rushing to it. But there are some strategic choices you can make on your way that will help you and place you better. So I've tried to gather some data and go through some different scenarios that you might encounter if you want to go out and into industry and create. So we're going to be starting off by talking about wealth. If we really want to go into industry, we probably partially want to do it for the money. So who's the wealthiest physicist? What do we need to do? According to Google, it's this guy. So that's easy. We just become physics teachers. Except they earn significantly less than the median wage for physicists. Okay, so at least if we just want to maximize money, we should probably use a different approach. If we remove some outliers, we can see this. I've chosen to give this data in percentage of the median wage because that should be relatively invariant across different countries. So as you can see, quantum computing expert leads this field, but it's also a very small field, so it's pretty difficult to get a job in it, and the data is a lot less stable than the next thing. Just go out and one. Because tons of people are doing it, and they're making a lot of money while doing it. So that was the approach I chose to take and kind of run with for this example. But as you can see, these are just the most heavily paid. Of course, each of them comes with a unique set of skills that you'll need to develop in order to excel at them. And I also looked into research on the influence of skill on your salary, and having the correct skill set for a task, not just enough to get hired, but enough to excel at it, can improve your salary by up to 5 times. So you should probably not just think about this money. It's kind of a caveat to all these numbers that I'm throwing at you. If you have, if you're good at something, if you're passionate about something, you should probably follow that over the other things. But software engineering is something we all learn at least some skills relevant to relatively quickly. So the roadmap starts here at ScienCon. You're already starting right off. Here, you'll meet some people, you'll get some ideas, and then you'll start planning. So, next step should probably be getting an internship. This, depending on your field, can be done in many different companies. There are loads of offers out there, both from big and small companies, where you can work more or less intimately with different groups. This gets your foot in the door at a company, and it shows future employers that you're used to working in a company. And that's a tendency you'll see throughout this talk. Because the next part is you write your master's thesis jointly with a company. Especially many big companies have established projects where you can solve interesting problems for them. This could be machine learning. We have Valeo making automatic cars here in Europe. We have Ineleo, who they do big data analysis. We have a lot of semiconductor research taking place, where data treatment is incredibly important. There are loads of things you can do here. Of course, I'm just engineering examples, but there are many paths you can take. Yeah, and This is the trick so nice, we'll do it twice. Because a PhD also makes you significantly more employable, write another project with a company. Now here you can, if you were satisfied with maybe the internship or the master's thesis you did, you can choose to do it at the same company, or you can spread your net, get a lot of choices. Now if you're doing all of these three things, and maybe even having a student job besides this, 4 different companies, this gives you a wide array of choices, and that's why the last point is there. Don't panic. This is the time now to breathe. You finished your PhD, the companies love you, you are a valuable asset, don't sell yourself too early. Take a deep breath and find a job that you'll actually be happy and satisfied in, and that rewards you commensurate to what you put in. And then finally, you start taking risks. We're at the final step of self-actualization. You choose what to do now. Here, we basically have 2 different options. You can either choose to keep on sweating for the man, working hard, developing your career and excelling in your field, or alternatively, you can say, well, a high hourly wage, if you keep that wage constant, you can choose to either try to get more money, or you can just use it to work fewer hours. Relax, enjoy your life. You might not need all of that money. Now, there are merits and problems with both, but generally, if you go hard in your career, if you keep on developing, you'll have to do a lot of taking up space. You'll have to do a lot of developing your softer skills, developing your management style, doing new things, trying to work with different areas, not being afraid to sign up for more projects at your job so that you develop a wide array of skills and tools that will allow you to manage greater and greater teams and greater projects. This gives you a huge impact on the world, and it gives you a huge amount of money. But with that said, it also takes a lot of time. You might want to relax more. You might want to focus more on your family. Here, you can also develop in all sorts of different ways. You can self-actualize in completely new ways that you wouldn't have the option of in your company, and you're still getting the money. So overall, a bit too fast. You can always come up to me and either ask questions about what I've read for this, or critique me, because honestly, I mean, I'm a bachelor student. I don't really know what I'm talking about. I'd love to hear how it actually works. That was my part.
Okay, I think like 50% of you will go with Cyrus, and someone around 50% will go the other way. But there is this small percent, really small percent, and my presentation will be for this really small percent of people. Because we talk about academia, we talk about business, but the question is there a third way? For example, just after you graduate, during your studies, you take this course on Coursera about this web development, and right now the companies are killing for you to get you on board. You are getting the offers of a huge amount of money, and well, 5 years of study. I will go making the web-based systems for banking systems or something like that. You are making a lot of money, or maybe you are not the one of the what is happening on academia. Maybe you are not you don't want to be part of it. So you are thinking 5 years of studies, or maybe more, and but you still have some feelings for the things that you loved in high school, that gives you these thrills when you were thinking about solving problems, looking at the world from different angle. So is there a third way? For example, can you have the paperclip company making a lot of money, nothing to do with physics? So can you do something to be a happy dead physicist? At the end, of course. So there is this idea of citizen science, of hacker science, of amateur science, but not in a bad way. Not amateur as someone who don't know what he's doing, but amateur in a sense that he's not getting money from it. The main goal is income. But I have a better one better for this. Oh yes, I like to call it Science Batman. So this idea of Science Batman or citizen science is someone who is doing the research because he wants it. He's doing the science because he loves it, and we are in the 21st century, the 2022 year, and we have a lot of options to do this. So, how to be Science Batman? You need three things: you need money, you need skills, and you need team. And I have a good news for you, everyone. You are using your own money because maybe you have a lot of money, or maybe the science you would like to do doesn't require a lot of money. The skills, yeah, you sure have skills. You just finished your study. The team. Well, the majority of citizen science research is open source, is crowdfunded. So the team is your whole world. So you can choose anyone on this planet who is willing to work with you. You have no boundaries. You have no limitation. No chief that will tell you what kind of research you should be doing. So there are a few examples. For example, Ben he have the YouTube channel and he's doing really crazy stuff. I mean, his own cold sputtering machine in his basement, and he can create really nice things. Also, there is so this guy called plasma in his own basement, like he's just doing this because he likes it, and he have like 700 subscribers on YouTube. And he's not doing the things that, he's not doing the popular science. His lectures are really complicated, like 30 minutes long, about one topic, quite boring. Okay. Also, there is this guy called Scotty Lab. He's like, he almost have a formal education, because he's a dropout from geological class. And he's 2 million subscribers, so it's a huge impact. I would like to have such an impact someday. And he's doing this just because he likes it. He doesn't get money from it. He's owning I think big rancho in Texas, and so he have money, he have a place where to do it. And the only thing is to doing something fun, entertain you, maybe. He just do it because he really likes science. So what's your prospect? So what can happen then? Like, this is the best part. At the beginning of this of our competition yesterday, the guys come up with this great statement: as our team cannot lose. You cannot lose because we cannot win. We are out of competition. And this is something like that. You can do whatever you want. You can do whatever you like in science. You love what about science you really love, because you are free from the bounds of business. You are free from the bounds of academia. You are just doing this because you love it. And this concludes my presentation.
Thank you very much for a very entertaining presentation. That was a little bit of a break for us when we were waiting for the part that I guess everyone are anxious about, which is of course who won this supposed competition. Because, as I said, it's more of a workshop than competition, but we still have rewards. Okay, I'm getting in circles now. So, I wanted to officially thank the Robotic Association of SCALP for coming here, observing, and also, which is very, very important, for helping us to organize this event on a very early stage when we were still looking for partners, looking for contacts, and only because of the SCALP Association we could contact so many great mentors. So thank you. And of course, as this event is officially an event of International Association of Physics Students, I would like to thank very much for active participation and helping us with everything to the Executive Committee of the International Association of Physics Students. And once again, if any of you isn't already a member of IAPS, join. Thank you.
Thank you.
Thank you. Okay. And now I need a moment to figure one thing out.
You might want to have that. I'll be that better.
Okay, yeah. Just give me a moment.
w kalendarze?
Nie, tak, to też, ale chodzi o coś innego. Delta gamma?
Jota, teta, eta. A tam 4 epsilon. Nie wiem, jak oni doszło.
Jota, teta,
To są kresy. Jota, teta, eta i delta gamma. Ja mogę przeczytać nazwę jak jest i ten. Ale mam z tobą być i mi gratulować czy coś? Może wręcz nagrodę drużyną sama, albo nagrodę dziękujemy wspólnie.
Okay, thank you. Thank you for your patience. That was a bit of a technical break to make it all smooth. And I would have a great one request last for the mentors, if they could come up here to the podium, to the scene. Yes, I'm sorry for that. Okay, so now we will be reading out the rewards and we will see which teams won. And after we'll give out all of the rewards, I would still ask mentors to stay with us just for 1 minute more. Okay, so as we mentioned before, there isn't first, second, and third place, basically. We chose one team in each challenge. So I will start with Ad Astra challenge, which was space exploration through physics. Oh, apparently, okay. Okay. That was a bit anticlimactic thing, but... So, the best team in the Ad Astra challenge, so space exploration through physics, is Delta Gamma! Woo! I'm sure that if you want, you can get a handshake as well for the future teams. Friendly handshakes, exactly. Okay, so now we will go to the challenge of the end is nigh. So the best project and career plan in the end of is nigh is Jota, Theta, Theta, Jota, Theta, Eta. Thank you for once again, the Jota, Theta, Eta. Maurice Rieger, Justyna Krystecka, and Joanna Buczkowska. Okay. I'm very sorry for the mix-up. Right. Greek alphabet is very hard after 5 years studying physics, apparently. Sorry about that, once again. And now we will go to the last reward. I mean, last but not least, of course. And the challenge is the dark side of digitization challenge. And the winners are Omega Psi Chi. Woo! Okay. And as I said, I asked the mentors to stay with us for a little while, and I think if I could ask for help, basically. Because if you could just without the mentors, this event wouldn't exist at all. I mean, without the mentors, you would have no one to turn with your doubts and with your questions. And without the mentors, you would simply plan and work the same way you do every day of your normal studies. So I wanted to say a big, heartfelt thank you to all of the mentors and each one of them as well. Okay, once again, thank you, and that's thank you for mentors. You're free to go, basically. And when it comes to participants,
maybe I can add a few sentences in the name of the mentors, because they were thanking us. I think they thanked participants and sponsors, and I think we should give a huge applause to the organizing committee for doing what they did and bringing to life this event. So I think it's a good opportunity for you to stand up and thank them for what they did.
Yeah, okay, that was longer than I expected.
That was not expected.
And woo! Yeah, we finally managed. Yeah, that's basically all. And of course our photographer, who's also there. Okay, so basically, what can I say at the very end of this event? Because to be quite honest, that was what I wanted to do next was basically to thank my volunteers and organizing committee and everyone who helped us. But fortunately, Tomasz did that for me, which I'm very grateful for. And basically, well, thank you all. Thank the participants. Thank everyone once again for making this event happen, because it's basically the kind of work that everyone had to be involved in. And now, on a very, very logistic note, at 7 p.m. there will be warm buffet in the mess hall, and then we'll have some great music from the band Skudacy Szczeremska, who already wait for you. And also at 8 p.m. we will fire up the campfire in the snow. So if someone is brave enough to brave the snow, you can go and enjoy the campfire. Thank you, and have fun. You definitely earned all this.